Hello everyone. In this video we'll solve example on normal distribution. Okay, so let us start with the example here. So in a sample of 1000 tube lights, the mean life and standard deviation of lines are 4500 hours and 1500 hours respectively. Assuming the distribution is normal, find the number of tubes lasting between 4000 6000 hours. Okay, so here the data given is n is equal to 1000, sample size is given, mu is equal to 4500 and sigma is equal to 1500 hours, right? And the distribution is normal. We need to find the number of tubes lasting between 4000 and 6000. So let us denote these 4000 as x1 and x2 becomes 6000 hours. Okay, so before to find number of tubes, first we will find probability of one tube which lasts between 4000 hours and 6000 hours. Then we will multiply it by 1000 tubes, so to get the number of tubes. Okay, so here x is a random variable which follows the normal distribution with mu sigma square, that is x follows mu as 4500 and sigma square 1500 square. Okay, so let us draw the diagram. This is x is equal mu is equal to 4500, and to find between 4000 and 6000 means 4000 means left hand side, that is less than 4500, 6000 is right hand side. Okay, so this is the required area which we have to find. Okay, now this we transform it to z transformation, that is z variable. So when mu is 4500 with the formula z is equal to x minus mu upon sigma, at this line mu and x both are same, that is 4500, mu is also 4500 divided by 1500. So value of z is equal to 0. So this line z is equal to 0. So we need to find z is equal to z1, that is when x1 is 4000, what would be the value of z1 that we need to find, and when x2 is 6000 we need to find the value of z2. Okay, and required area will be in between z1 and z2. Area means here we are going to find probability between z1 and z2. So let us start with the formula. Z1 is equal to x1 minus mu upon sigma. Here x1 is 4000 minus mu is 4500 divided by 1500. So which gives minus 500 divided by 1500, which is minus 0.333. Okay, now this is z1. Similarly z2 is x2 minus mu upon sigma. Here x2 is 6000, mu is 4500 divided by 1500, so which gives 1500 divided by 1500, that is 1.00. So the question which we are going to find is, for one tube, probability between x1 less than or equal to x less than or equal to x2, which is probability between 4000 hours and 6000 hours. Now it is equivalent to find probability between minus 0.333 less than or equal to z less than or equal to 1.00. So now random variable x converted to the standard normal variate z by using the formula x minus mu upon sigma. So let us represent this using the diagram, using the normal distribution curve. So here z is equal to 0 and this is z is equal to minus 0.33. So negative values will be at the left hand side and positive values will be at the right hand side of z is equal to 0 line. Now the required area becomes in between two lines. Let us represent z1 and z2. Okay. So this is the required area. Okay. So that is, to find this means probability of what it representing us from minus 0.33 to 0. It is nothing but sum of two regions. First region is minus 0.33 and second region is 0 to 1. So we will minus 0.333 less than or equal to z less than or equal to 0 plus probability of 0 less than or equal to z less than or equal to 1.00. Okay. Now as this z is equal to 0 is the symmetry line, minus 0.33 to 0 is equivalent to 0 to 0.333 and second probability will remain as it is. Okay. So how can we say the symmetry here? So shortly we will draw on one more diagram. Z is equal to 0. Z1 is equal to minus 0.333. So the area which is between two lines now is it equivalent to z1 is equal to plus 0.333. It is similar to this area. Okay. By as z, this line is the line of symmetry, so the minus 0.33 to 0 is equivalent to 0 to 0.33. Okay. Because the table which we are going to use is from z is equal to 0 to z is equal to some z1. So always we need some 0 to z1, 0 to z1. So let us use the table. Z is equal to 0.33. Two z's will consider. So here z is 0.3 will see the vertically, and one more 3 means here third column will check. So the common intersection value is 0.1293. Okay, so here we'll write probability from 0 to 0.33 is 0.1293 plus again we'll check now for z is equal to 1. Okay, so z is equal to 1 means 1.00. So 1.0, the zeroth column, the value is 0.3413. It is 3413. So let us write in the example 0.3413. So the addition becomes 0.4706. Now this is the probability of one tube which lasts between 4000 hours and 6000 hours. We have to find how many such tubes are there out of 1000 sample. Okay, so the number of tubes having life between 4000 hours to 6000 hours is total number of sample, that is n, multiplied by 4000 less than or equal to x less than or equal to 6000. But this we have converted into z variable, so which is minus 0.333 less than or equal to z less than or equal to 1.0, and that probability we have, so 1000 multiplied by 0.4706, approximately it is 472 tubes are there. So as per the question, the number of tubes are 472 lasting between 4000 and 6000 hours. So in this way we can solve the numerical or example using normal distribution.